Hi, welcome back to section 10.3. The next thing we're going to look at is the distance formula. So basically, if I give you 2 points, can we find the distance between those 2 points? So I have it kind of out here. You can see it on the PowerPoint and on my paper. So the first point, I'm just saying the x-coordinate is x1 and the y-coordinate is y1 for the first point. And the second point, I'm just saying the x-coordinate is x2 and the y-coordinate is y2 just for the second point. And we would like to find the distance, so the straight distance going from point 1 to point 2. Okay? And essentially what we're going to do is we're going to use the Pythagorean Theorem, which is kind of fun. So refresher, Pythagorean Theorem says for a right triangle, a squared plus b squared equals c squared. Okay? So c squared is your hypotenuse, a and b are your legs of your right triangle. So let's look at the lengths of our legs. So the length at the bottom, down here, would be the distance between my x's. So this one would be x2 and this one would be x1. And so to find that length, what we're going to do is just subtract them. We're just going to do x2 minus x1 just to get that length of the bottom part here. For this vertical one up here is y2 and down here is y1. And so if you want to find this length right here, we would just subtract. We do y2 minus y1, and that would give us the length of that side. Okay? So when you're applying that to the Pythagorean Theorem, a squared plus b squared equals c squared, what's going to happen is for a squared, we'd have x2 minus x1, so subtracting our x-coordinates, squared, plus b squared, so that would be y2 minus y1 squared, equals c squared, and c is our hypotenuse, it's the distance. So I'm just going to call that a d for distance squared. So if you just want to solve for distance, the opposite of squaring is square rooting. So you just take the square root of both sides, and that's where the distance formula comes from. So distance is the square root. It'll be the positive square root. We're not doing plus or minus because distances are positive, of x2 minus x1 squared plus y2 minus y1 squared. Okay? And basically, practically, when you do this, we're going to follow order of operations. So you're going to subtract your x's and square them. You're going to subtract your y's, square them, add those things together, and then take the square root. Basically, being underneath the square root, there's kind of these like assumed parentheses right here that hold everything together. So let's go ahead and try one of those. So example 4, points I gave you are, we want to find the distance for the points, between the points 2, -1 and 5, 3. Okay, so my distance equals the square root of x2 minus x1. So my x-coordinates are 5 and 2, so I'm just going to do 5 minus 2 squared. Plus, we've got y2 minus y1 squared, so these are my y-coordinates, -1 and 3. So if I subtract them, I'm going to have 3 minus -1, and then I'm going to square that. Okay? So again, with order of operations, I'm going to do parentheses and then exponents, and then I will add, and I'm going to do the square root last because everything is underneath the square root, and you've got to get it all together first before taking that square root. Okay? So from here, 5 minus 2 is 3, so I've got 3 squared. 3 minus -1 is the same thing as 3 plus +1, which would be 4 squared. Okay? And let's see here. We've got 3 squared is 9. 4 squared is 16. So now I've got 9 plus 16, which would be 25. And then I'll take the square root of 25, which is 5. Now this one turned out as a perfect square. They don't always. If they are not a perfect square, you'll simplify it, or you can do an approximation depending on what the problem is asking for. Okay? So now it's your all's turn. You get to try one and show me how much you've learned.